Example 1 says, find the next 4 terms of each sequence and explain why. About anybody else?
Yeah, I'm trying to see. I was just going to pick one of us. There. I don't know what's wrong.
Okay, so here we go. Here are the sequences. So I want you to tell me the numbers, the next 3 numbers, and then tell me what the pattern is going to be too. So I want the next one, I'll yell them in a sec here, the next 4 numbers. So the first sequence is one everyone should be able to get. The way this unit goes is that for some people, these numbers are really easy, the patterns here. For others, it's more difficult. Okay, so again, for some people, these will be completely obvious. For others, they'll say, I don't quite get it. If you're in the group that say, I don't quite get what the obvious patterns are there, they're not obvious, okay? We will learn in this unit how to find this stuff. So I'll take those headphones off, and then I'm going to yell at those guys right now. To be brave, and to start with letter B for me, please. What's the pattern, first of all? Pattern? Go ahead. Good. So we're going to multiply this one by -3. Did you get the last 4 numbers, please? Can you get the numbers, please?
162.
Yeah.
-46.
Yeah.
Then 48.
Is there another one too? There should be 4, right? Did I say 3 or 4? I said 4. Negative, what is that? I can't figure it out. 6. 374. Okay, good. Now letter C is a little bit more complicated. Did anyone see that one? Madison, go.
Okay, I know it's probably something more complicated, but I just did like 1 plus, or 1, 3 minus 1 is 2, and then you just keep adding up. So 10, it'd be 10 plus
2, plus 3, plus 4, plus 5, which is going to give us 15, plus 6, which is 21, plus 7, which is 28, plus 8, which is 36. Now, that's good. Let's go back to grade 10, 9, and 10. What did she just actually find there? What did she calculate?
Steps.
Good. Let's go back to the math terms, though. Back to grade 9 or grade 8. If you're subtracting 2 numbers, what's that called? In a table. First differences. Good. If the first difference has a difference of 1, what does that tell you? The second difference is going to be the same, so it's going to be quadratic, okay? So that actually would be quadratic if we were to graph it, okay? So if we make the equation of something like letter C, it's going to be quadratic, right? Letter D is a little bit more awesome. Just say the pattern is increasing by 1 more each time, you can say. I'm going to have to bring these to the next page. Now we're starting to get to the fun ones. Okay. Has anyone got D down? Go ahead. Yes. Good. Okay, so what the pattern is for this one, which is awesome, this is called 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21, then we have 34, 55, and 89. This is called adding the 2 previous. This has a scientific name. I know half of you are in biology. Did you get a test this morning? Anyone see this pattern before in science? Give me a hint, it begins with F. Run starts with failed? No. Fibonacci sequence. Fibonacci sequence. This is actually the main application of like growth of anything, insects, like anything, growth of anything, okay, as far as generations, let's start with 2 individuals and then 2, 3, 5. Fibonacci sequence might be Fibonacci. All right, 14916, this one's again another tricky one. Has anyone ever seen 14916 before in your life? Glenn, go ahead.
Okay.
No? Okay. No? Go ahead. Yeah, squares. So this is going to be 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared, 25, 36, 49, 64. Those are squares. Okay, there is another pattern here too if you really want to get crazy. So did you see another one for E? Good, and that works. That's another way to do it too, right? So the other way to look at it, and that's not wrong, there's more than there's multiple ways to get it. So you said this is plus 3, plus 5, plus 7, plus 9, plus 11, plus 13, plus, and that works as well too, right? Either of those work. So you can either say if you want the squares, right? So, or, all right, 4, 8, 15, 16, 23, 42. Anyone ever see that before? This is such, I'm so old. Anyone ever see Lost? These are the Lost numbers, actually. So. And actually, not if there's a show called Lost, it's old, but that was supposed to be the key numbers. That there's no pattern. Mathematicians have actually studied these numbers because they made it on the show and they're supposed to have some deeper secret meaning. So mathematicians studied these numbers to find the next number in the pattern, and there is no pattern to those numbers. But there's no, exponential, logarithmic. There's no thing. Well, that's one that this was not an ordered list. This is not a sequence. So no pattern. No, they don't. They stopped there in the show. But they put this into like every supercomputer equation. Like people get weird about TV shows, right? Right. So they put it into like a giant, thing, and they couldn't find the next number. All right, here we go. Sorry, that's my bad show. So we're going to say, yeah, sorry about that. So we're going to say in math class, we label our numbers, label our terms, sorry. So T4 equals the 4th term. T11 equals the 11th term. Tn is going to be the nth term. The general term. The general term I'll get a little later, sorry guys. The general term is the. Can you do this, guys, please? No, you didn't. Hold on a sec. 1 sec. Is the equation that makes any other term in the sequence. Okay, let's see this pattern. I'm going to hit pause here so the internet doesn't need to hear this. I